This lesson is going to go over simplifying algebraic expressions. In other words, it is when we are combining like terms. By the end of class today, or in this video, you should be able to say that I can simplify algebraic expressions by combining like terms. In this presentation, we're going to learn about parts of an algebraic expression. We're going to learn about what like terms are. And we're going to learn how to simplify algebraic expressions by combining like terms. So we're going to review what we've learned so far about algebraic expressions, and this is what we talked about on our virtual Monday. An algebraic expression is a mathematical phrase that uses numbers, variables, and operation symbols. In other words, just to give you an example, if you had the algebraic expression 3x plus 4, we're using numbers, which would be 3 and 4, variables, which is our x, and operation symbols, which might be addition, subtraction, multiplication, or division, which in this case we're using addition, to write basically a math sentence. We read this as 3x plus 4. So we're reading it as a math sentence, which is an algebraic expression. The reason we call it an expression is because it does not have an equal sign. It does not have an equal sign. Equations have an equal sign. Okay. So here's another example. 2x plus 7 is an example of an algebraic expression, very similar to what I just wrote. 2x, 7, these are all variables and numbers, and our operation symbol here is a plus sign. So a variable, it's a symbol that stands for one or more numbers. And as we go through these next couple of slides, we're going to talk a little bit more about what each of these symbols in our algebraic expression stand for. Okay, so in an expression, you have something called terms. And everything in an expression is considered a term. And that is why in this slide, every single term is highlighted green. So 5x is a term, 3y is a term, and negative 8 is a term. So these are all terms. But specifically, these terms are either called variables, coefficients, or constants. So let's talk about coefficients. Coefficients are the numerical factors, which is a fancy way of saying the numbers that you're multiplying a variable by. So when we're looking at these coefficients in red here, the coefficient of x is 5, the coefficient of y is 3. And when I say coefficients, I think about like a co-pilot. It's someone that's next to you or a partner. So when we're looking at x, its coefficient is 5. When we look at y, its coefficient is 3. And what's really happening here is, and we've talked about this before in other problems, there is a multiplication sign that is in between this coefficient and this variable, but we just don't always write the multiplication symbol. So this is the same thing as 5 times x. This is the same thing as 3 times y. In other words, you have 5 x's here, you have 3 y's here. So your coefficient is always the number that is before a variable or attached to the variable. Variables, as we stated before, is a symbol that represents numbers that are unknown or can change. And the reason we say that is that's what vary means. To vary is to change, or it might be something that we don't know what it is yet. So it's unknown or it can change. So x and y in this expression, we could put maybe the number 4 in for x, and we could put the number 6 in for y. But then we could try to put in, I don't know, 4 for x, and maybe this time, oh, I just already said 4, my apologies. Let's say, I don't know, 7 in for x. Maybe this time we put in 5 for y. And depending on what number we put in for the variable is going to change our answer. So that's why the variable can change depending on what we would put in for x and what we would put in for y. And last but not least, we have something called a constant. And like I've told you guys in class before, normally math terms are pretty black and white and you can find a clue as to what they mean. So when you guys just think of the word constant, if something is constant in your life, if something's constantly happening, it means that it doesn't change. It stays the same. So if you look at this -8 here, that -8 doesn't have a variable attached to it. So it's just going to stay -8. It's going to be constant. It's not going to change. So a term that has no variable, it's just a number by itself, is a constant. Okay, so what we're going to do is we're going to take these algebraic expressions and we're going to simplify them. And it literally means to make the problem simpler. In other words, when you rewrite the expression in the most compact way without changing the value of the expression, it's like organizing the expression to make it neater. In other words, if mom or dad tell you to clean your room and you organize it, it's a lot easier to find things, right? Because you have organized your room or you've organized your space. And that's what you can do with math as well. If you keep it organized, it can be a little bit easier to solve. So let's take a look at this example here. Now, before we get into the math piece of it, I want to just talk to you about if you went to the drive-thru to order food and you told the drive-thru that you wanted 1 cheeseburger, you wanted 1 hamburger, you wanted another cheeseburger, let's throw in there 2 hamburgers, maybe 1 thing of fries, oh, and I want 1 more cheeseburger. So if you went through the drive-thru and said, I want 1 cheeseburger, 1 hamburger, oh, 1 cheeseburger, oh, 2 hamburgers, 1 fry, 1 cheeseburger, you know, that's a lot for someone to have to remember, and things are kind of scattered all over the place. So instead of doing that, normally what you just do is, well, let's see how many total cheeseburgers I really want. Well, I want 3. So it's just a lot easier to say, hey, I would like 3 cheeseburgers. And how many hamburgers did we really want? Well, we wanted 3 hamburgers. So let's just call that 3 hamburgers. And we wanted a side of fries, so that's 1 side of fries. So when you go through the drive-thru, it's a lot easier to say, I'll take 3 cheeseburgers, 3 hamburgers, and a side of fries, rather than saying 1 cheeseburger, 1 hamburger, 1 cheeseburger, 2 hamburgers, 1 fry, and 1 cheeseburger. The same is true for math. Looking at this expression right here, you have x plus 4 plus 3x plus 2x plus 12. And there is a way that we can simplify it by combining like terms to make it just a more simple expression. So what I'm going to do is I'm going to take a color here, call it purple. And I see that I have an x here. I have 1 x here. Well, where else do I see x? Well, I've got 3 x's right here. So I'm going to go ahead and put a purple box around that. And I have 2 x's right here. So I'm going to put a purple box around that. And I can show this to you visually as well. So we've got 1x, and then let's say we've got 3 x's, 1, 2, 3, and then we said we had 2 x's, 1, 2, okay? All right, now I'm gonna take a different color, and I notice I have a constant of 4, right? I have a constant of 4. This doesn't have a variable with it, so I have 4 here. I'm going to circle that in like a turquoise. Well, I also have another constant over here. This is just 12. So I'm going to circle that in turquoise. And to show this here visually, I'll go ahead and I'll draw 4 dots. And then here I'll draw 12. Okay, so what we're going to do here is we're going to simplify this expression by combining like terms or putting together like terms. Now, when you see like terms, what that means is they have to be the same. So let's go back to our color coding here. I see that I have 3 x's, 1 x, and 2 x. So I can take all these x's because they are the same terms and put them together. Well, how many x's do I have then? 1, 2, 3, 4, 5, 6. And if you added them up here, you would see 1, 2, 3, 4, 5, 6. So that is the same as 6x. Well, then I'm going to go ahead and look at my constants. I have a constant of 4 right here, and I have a constant of 12. Well, I can take those constants, I can group those together, add them, and 12 plus 4 would give me 16. So my simplified expression, when I take the like terms and put them together, would be, and I'm sorry, that looks kind of like a negative there, would be 6x plus 16. So this big long expression up here of x plus 4 plus 3x plus 2x plus 12 is exactly the same thing as 6x plus 6. It's just simplified, it's more condensed, it's a little easier to work with. Now let's take a look at this expression. You have 5x plus 3y plus 8. I cannot simplify this expression anymore because we have x here. We have a different variable here, y. They're not like terms. Because they're using two different letters, it means they're representing two different numbers. So we can't combine these. So this is as simple as this expression can get. So let's take a look at this one. They're using different letters, but they're still considered variables. And I'll go ahead and show you again with a picture. So I'm going to circle this in pink. This is 2n. I'm also going to circle this n here because I know it means 1n, right? It's really the same thing as having a 1 out front. We just don't always write that. And that's really it. I don't see any other n's here. So these are the only like terms that I see that I can combine that involve an n. So if we have 2 n's here and we have 1 n here. Okay. Go ahead and take a different color. And I see here I have this constant. I have this constant 4. Go ahead and circle that in blue. I don't see any other constants, so it looks like that guy is just going to kind of stay by himself here. Oops, I did 6. Okay. And then we have 7h. I'll go ahead and put a box around that in green, 7h. But remember, just because we have a variable doesn't mean that this is the same as having n. N and h are different variables, so you're not going to combine those. They are not like terms. And we'll use, let's see, squares for h. Okay, so when I go to combine this all together, I see I have 3 total n's, so that is 3n. I have just 4 as a constant, so I'm going to call that 4. And I have 7h. So this is your simplified expression here, but it is etiquette in math that you actually want to write your variables before you write your constants. So I'll probably rewrite this as 7h plus 3n plus 4. This one is 11x plus 9 plus 7. This one's relatively easy to simplify because you'll notice the only variable that we have is 11x. It means we have 11 x's, but we don't have any other x's in this expression. So that's already simplified. But what I can do here with my constants is I have a constant of 9 and a constant of 7. So if I add 9 and 7 together, that will simplify my expression to 11x plus 16. Go ahead and pause the video if you can and try these next 3 on your own. When you're finished, I will go ahead and do these 3 to see if you got them correct. All right, the answer to number 1. I would combine the like terms, 4a and 2a. They're both positive, so 4a plus 2a is 6a with 7 as my constant. It doesn't have another constant that goes with it. Down here for number 2, my like terms for x, I have a 4x, I have a 3x. So 4x plus 3x is 7x. And then 3, 8, and 2 are all positive constants. So let's see, 8 plus 3, 8, 9, 10, 11, 12, 13. So let's add 13. And last but not least, I have 12h, I have 1h, and I have 2h. So if I add those together, 12 plus 2 is 14, plus 1 is 15, so that is 15h. And then I add my constants of 17 and 16, which is 33. So 4a plus 7 plus 2a is equal to 6a plus 7. 4x plus 3 plus 3x plus 8 plus 2 is equal to 7x plus 13. And 12h plus 17 plus h plus 16 plus 2h is equal to 15h plus 33. Okay, so that's a little bit on how to simplify expressions. Make sure that you guys are keeping up with your IXLs on your weekly learning plans. You can also always get on Khan Academy and search for simplifying expressions, and you can find lots of extra practice there as well.